Hello again. Today we're going to be solving linear systems by linear combinations. So if you've seen some of my other linear combinations videos, you'll know that I like to look for opposites so that we can eliminate one of the variables. So I see here I have a 3x and a 4x. Well, those aren't opposites. And I have a negative 2y and a negative 3y. Well, those aren't opposites either. So what I'm going to do is I'm going to multiply both the top equation and the bottom equation by something that is going to make one of the variables cancel. So what I need is for them to be opposites. So I will multiply the top equation by 4 because I want to get rid of my x. And I will multiply the bottom by 3. But if you see, if I multiply 4x, or 4 times 3x, and 3 times 4x, I'm going to get 12x on top and bottom. So that means I need to multiply one of my equations by a negative as well. So I will choose to make the bottom one the negative. Now I will do distributive property on everything. Okay, so on top, it's 12x minus 8y equals 8. For my bottom equation, I got to do distributive property on everything so that it's negative 12x plus 9y equals negative 3. So now I can do my linear combinations. So my 12x and negative 12x cancel. Negative 8y plus 9y is 1y, which is just y. And 8 minus 3 is 5. So y is 5. I will take this value for y and I will plug it into either one of the original equations. I'm going to choose to plug it into the first equation. So I have 3x minus 2 times 5 equals 2. Well, now I have 3x minus 10 equals 2. I'm going to add 10 to both sides. Those 10s cancel. I'm left with 3x equals 12. I'll divide both sides by 3, and x equals 4. So now my ordered pair is 4, 5. I'm going to test my ordered pair in both equations. So I will say 3 times 4 minus 2 times 5 equals 2. Well, that's 12 minus 10 equals 2. 12 minus 10 is 2. 2 equals 2. Check. My next equation, if I plug in 4 times 4 minus 3 times 5 equals 1, that's 16 minus 15 equals 1. 16 minus 15 is 1. 1 equals 1. Check. So the solution is 4, 5. Now, it also works the same way if you want to cancel y. All right? So let's say I want to cancel the y's. Well, I see here I have a negative 2y and a negative 3y. So because this one is negative 2, I'm going to multiply the top by 3, and I'll multiply the bottom by 2. But since they're both negative, one of them needs to be negative out front so that they will be opposites. So now I'll do my distributive property on the top, and that gives me 9x minus 6y equals 6, and negative 8x plus 6y equals negative 2. Well, I'm going to do my linear combinations here. I have 9x minus 8x, that's x. My negative 6y and my 6y cancel, equals 4. All right, so now I can take that 4 and I'm going to plug it into this equation this time. So now I have 4 times 4 minus 3 times y equals 1. So I have 4 times 4, that's 16 minus 3y equals 1. I subtract 16 on both sides of the equation. That 16 cancels. I'm left with negative 3y equals negative 15. I divide both sides by negative 3, and y equals 5. So my ordered pair that is a solution is 4, 5. Same answer we got last time. But I wanted to show you that you could do this by canceling either x's or y's.